Hello everyone and welcome back to my channel. Have you ever wondered how we can make those language models like GPT-4 even more wonderful? Well, the secret is chaining them together. Think of large language model as a brilliant mind, each with their unique strengths. For simple tasks, they work solo like a champ. But for complex tasks, it's like assembling an AI superhero team, each with their specialized superpower. And that's where LangChain Chains comes in. Chains are like the glue that connects these AI superpower together, allowing you to build mind-blowing applications that can do things like question answering by searching massive database, create unique stories or poem on demand, powerful chatbots that hold meaningful conversation. In this tutorial, I will unlock the secret of LangChain Chains. We will start simple, and then we will dive into sequential chain. And even more, I will show you how to create your own custom chain from scratch. Get ready to level up your AI game today. By the end of this tutorial, you will be designing complex AI workflow that can solve any challenge. So let's dive into the fascinating world of LangChain Chains. In this tutorial, we are going to build two chains, simple chain and sequential chain. But first, we have to prepare our Jupyter notebook. So let us first start installing the required libraries. So for this tutorial, we want to install openai library, LangChain library, and python-env library. So we'll say pip install openai, pip install LangChain, and then pip install python-env. Let's run the code. Next, we are going to load the environment variable. For this, we are going to create a function called setup_openai. This function will initialize the OpenAI client with the API key, and it will set up the OpenAI client so that we can interact with OpenAI API for various language model tasks. And at the end, this function will return an instance of the OpenAI client configured with our own API key. So let's define the function setup_openai. First, we are going to import OS, and then from openai import openai from .env import load and find_.env. We are importing the function to load the environment variables. Next, we are going to load the environment variables from the .env file located in the same directory as this Jupyter notebook. So we'll say load_.env find.env and override equal true. Then we are going to retrieve the OpenAI API key from the environment variable. So we'll say API key is equal to os.environ.get OpenAI_API_key. Next, we are going to create an instance of the OpenAI client with the retrieved API key. So we'll say client is equal to OpenAI, and then API_key is equal to API_key. After that, we want to print a message to confirm successful API key loading. So print API key loaded, and then the condition is API_key is not none. And finally, we are going to return the client. Let's run the code. Next, we are going to create our OpenAI client. So we'll say client is equal to setup OpenAI. Let's run the code. and we get the result, API key loaded true. In the next part, we are going to start building our first chain, which is going to be the simple chain. Simple chains are the foundation of the LangChain framework. They consist of a single large language model, which is used to perform a single task, such as generating text, summarizing information, or answering questions. Think of them as the building block of a more complex AI application. Simple chains are easy to create and understand, which makes them a good entry point for anyone new to LangChain. However, their capabilities are limited to a single operation. If you want to create a multiple operation in sequence, then you have to look for a more advanced chain type, such as sequential chain, which we are going to cover later in this tutorial. For now, let us start building the simple chain application. For building the simple chain, first we have to import the wrapper to interact with OpenAI language model. So we'll say from LangChain underscore OpenAI import chat OpenAI class. Next, we have to import the prompt template class for defining prompts. So we'll say from LangChain import prompt template. After that, we are going to import the large language model chain class to create a chain of operation. So from LangChain .chains import LLM chain. Next, we have to initialize the language model using OpenAI. So we'll define an object, large language model, LLM is equal to chat OpenAI. The default model is GPT-3.5 Turbo. Next, we are going to define our prompt template. So let's define our prompt template. We'll say you are an experienced data scientist with over 20 years of experience. Write a few sentences about the following topic. Say topic in language. We are defining two input variables, topic and language. The topic, what we want him to write a few sentences about, and the language that we want these sentences to be. All right. After that, we have to create a prompt template object from this template string. So we'll say prompt underscore template is equal to prompt template dot from underscore template, and for template is equal to template. Okay. Now it is the time to construct our large language model chain. So we'll define a chain is equal to LLM chain. First, we have to initialize the OpenAI language model. So we'll say LLM is equal to LLM. And then we are going to pass the prompt template to the chain. So we'll say prompt is equal to prompt template. And then verbose is equal to true. You can set it to false, but I set it to true to print the interaction between the large language model and the prompt for debugging. Now we are going to create a dictionary to pass the variable into the prompt. So we'll say input underscore variables is equal to topic, and for topic I'm going to choose automatic speech recognition, and for language I'm going to choose Spanish. All right, now we are going to execute our change. So we'll say output is equal to chain dot invoke, and I'm going to pass the input variables. Okay, let's run as a code cell and make sure everything is working fine. And it is successful. As you can see here, this is the prompt that we used here. Okay, now let us print the output and check the result. So if we can say here print output, And let's run the code. Let me just scroll up a little bit. And we get the result. Automatic speech recognition, language Spanish. I don't understand Spanish, so let's change it back to English and check the result. English, run the code. And again, here we will print the output. And we get the result. Automatic speech recognition is a technology that allows computer to transcribe spoken language. All right. So this is just an example of the simple chain. Now let's have another example. So we'll say template is equal to what is the capital of country, list the top 3 places to visit in that country. Use bullet points. Again, we'll say here prompt underscore template is equal to prompt template dot from underscore template, and template is equal to template. Again, also for the chain, we are going to initialize it here. We'll say equal to LLM chain. LLM is equal to LLM. Prompt is equal to prompt template. And then verbose is equal to true. For country, it's going to be equal to input, enter your country. Okay. And for output is going to equal to chain dot invoke country. Finally, we are going to print the output. Okay. Let's run the code and make sure everything is working fine. Enter the country. Let's say United Kingdom. And we get the result. The country United Kingdom, the capital is London, and here are the 3 places to visit. If you want to see only the text, we can say the following: print output text. Let's run the code. So we have the capital of United Kingdom is London. Top 3 places to visit are Palace, the British Museum, and the Tower of London. Finally, as I said, simple chains are easy to create and understand, and they are a good starting point to start learning LangChain chains. And as you can see, they consist only of a single large language model. In the next part, we are going to start building the sequential chain. For complex tasks, it's often necessary to use sequential chain. With sequential chain, you can make a series of calls to one or more large language model. The output of one chain is used as input to the next chain. There are 2 types of sequential chain: simple sequential chain and general sequential chain. Simple sequential chains are ideal for scenarios where each chain has a single input and single output, and the output of one chain is used as input to the next chain, which makes them perfect for scenarios like generating and refining text or extracting and summarizing information. General sequential chains are more flexible, handling scenarios with multiple input and multiple output, which opens the possibilities for more advanced AI application. Let us now start building the sequential chain example. Well, alright, for this example of sequential chain, we are going to create 2 chains. The first chain will be used to write a function that implements a concept, and the output of the first chain is going to be used as input to the second chain. So this sequential chain will contain 2 chains. So let's start implementing the sequential chain, and then you will understand. Okay, so we'll say from LangChain underscore openai import chat openai. Then from LangChain import prompt template. Then from LangChain.chains import LLM chain, and we want the simple sequential chain. Okay, let us now define our first chain. So we'll put here first chain, say LLM1 our first large language model is equal to chat openai, and the model underscore name is equal to GPT-3.5 turbo. Okay, and for temperature it's going to be equal to 0.5 to avoid hallucination. Okay, now we will define our prompt template for code generation. So we'll say prompt underscore template 1 is equal to prompt template dot from underscore template, and the template is equal you are an experienced scientist and Python programmer. Write a function that implements the concept of concept. Okay, so the first chain is going to write a function, and this function is going to be used as input to the second chain. Let's continue. So we'll say here chain 1 is equal to LLM chain, LLM equal LLM1, and prompt is equal to prompt template 1. Okay, now let's create the second chain. So we'll say here second chain, LLM2 is equal to chat open AI, and model underscore name is equal to GPT-4 turbo preview, and temperature is equal to 1.2 for creativity. After that, we are going to create the prompt template. So we'll say prompt underscore template 2 is equal to prompt template dot from underscore template, and template is equal, given the Python function, the function that was the output of the first chain function, describe it as detailed as possible. Next, let's create the chain. So we'll say chain 2 is equal to LLM chain, LLM equal LLM2, and prompt is equal to prompt template 2. Okay, next we have to combine the two chain into a sequential chain. So here create the sequential chain. So we'll say overall underscore chain is equal to simple sequential chain, and we are going to pass chains equal to chain 1 and chain 2, and verbose is equal to true. Okay, now let us run the overall chain with binary classification as input for the first chain. So we'll say here output is equal to overall chain dot invoke, and we are going to pass binary classification as a concept, and let's print the output. We'll print here output and output. All right, so let's run the code and check the result. Take a look at the debugging information that is being displayed. You can see that each prompt template and how the actions are invoked. This is the first chain that implements the Python function for binary classification using the model GPT-3.5 turbo. And this is the second chain that uses GPT-4 turbo and describes the function as detailed as possible. And here it is finished, and here's the output of the sequential chain. Now you know what chains are and what they can do. You also learned that there are two types of chains, simple chain and sequential chain. The type of chain you use will depend on the task you are trying to accomplish. If you are trying to do a simple task, a simple chain might be good enough. But if you are trying to do a complex task, a sequential chain is what you need. We have only scratched the surface of what LangChain Chains can do. There are many other types of chain to explore, each with own capabilities and applications. I encourage you to keep learning, experimenting, and pushing the boundaries of what AI can do. If you have any question or cool ideas of using LangChain, don't hesitate to share them in the comment below. Thanks for watching and stay tuned for more tutorial on how to unleash the power of AI with LangChain.